Our next speaker is Josh Aleri. Josh has travelled a long way. He's come the whole way from Melbourne in Australia, and he's going to talk today about the associations between immune competence, responsiveness and production in Australian heifers. Thank you very much, Josh.
Thank you, Mr. Chair. My talk today, it's a build-up from my presentation yesterday, which was about controlling or mitigating the transitional stage diseases using long-term strategies, immune competence. So this is just a study which is part of a bigger project looking at immune competence as a survival or longevity trait that can be used to improve the health and welfare of dairy cattle. And today I'm lucky to have part of the team here, Andrew Fisher, Peter, and Michael Pyman. Straight to the introduction. As we all know, the transitioning stage or peripaturient period is quite a stressful time period within the dairy farming for the farmers and also for the welfare of the dairy cattle because of the high incidence of both infectious and metabolic conditions. And a lot of reports or research has shown that the nutritional problems are such as risk factors and also genetics and also immunosuppression, which I talked about yesterday. So when you're looking at control strategies, you have to incorporate these risk factors. So in our research group, we are focusing mainly on a long-term strategy, which is called immune competence testing. And we've been lucky to be able to measure immune competence. So just remember, it's important, if you can measure that trait, it's very important because you can be able to improve it. And if you can't measure, you can't change it. So what's immune competence testing? So this is simply a holistic approach that involves identification and selection of animals based on their immune response. And it's also beneficial because we are able to incorporate other longevity or survival traits, including production. So the objective of this study was to look at the relationships between immune competence with two important production or health parameters, stress responsiveness and resistance to internal parasites. So we did a longitudinal study, or prospective study if you like, and this was done in Victoria, down there. So we used two farms, two typical pasture-based farming methods, and we used 400 heifers, approximately 200 from each farm. And we collected data at pre-joining, and this involved the immune competence testing and also fecal egg counts at pre-joining. Then followed all through these heifers into their lactation cycle just to collect the production data such as somatic cell counts and milk yield. So this is just a quick overview of the immune system. And we have the innate at the top, which is supported by adaptive, and the adaptive has two arms and the overall immune response. So what we're measuring is adaptive immune response and the cell-mediated, and we combine these two to have an overall immune response. So other parameters that we did assess were stress responsiveness, and this, based on the protocol that we developed, we stressed the animals using short-term handling and yadding, and we assessed plasma and cortisol levels. So for internal resistance to parasite, we collected stool, and we were able to assess fecal egg counts. And as I mentioned, the other data, which include somatic cell counts, which will not be presented here, was followed through the first lactation. So an overview of our results, we had immune competence data, which were three: antibody-mediated immune response, cell-mediated immune response, and combined immune response. With the health data, we also had the internal resistance to parasites, and stress responsiveness. So what we were aiming to look at was a correlation or associations between immune competence as a trait with its production and or health parameters. So this is just a quick overview of the model. And we had a antibody-mediated immune response, cell-mediated, and combined. So within this column here, we have 3 groups: low, medium, and high, or average, which represent the categories of immune response that we were able to group the animals using a model. So if you zoom in, those are the results. So you can see the low immune responders for antibody-mediated immune response had a little bit of high cortisol responses, similar to the cell-mediated and combined. And we are ideally interested in combined immune response, because if we select animals based on one arm, you might suppress the susceptibility or increase susceptibility towards other diseases. Then a quick snapshot on the correlation for immune response and fecal egg count. So this is a graph which shows you that with increased immune response, you have low fecal egg counts, and with high fecal egg counts, there's low immune response. And this is for the antibody-mediated immune response. Then with the cell-mediated immune response, there was no correlation, as you can see, or insignificant. So looking at these results together, we are able to observe that animals with combined immune response had higher plasma or cortisol stress responses. And this was also supported with a significant negative correlation between antibody-mediated and stress responsiveness. However, there was no correlation with combined immune response, cell-mediated immune response. And also, on the fecal egg counts, there was a negative correlation between antibody-mediated immune response and resistance to internal parasites. So what does this mean for us? So if we look at this diagram, we have the innate immune response, which is the first line of defense, supported by the 2 arms of the acquired or adaptive immune response, which we were able to measure as a trait. And this is supported by genetics, which we are lucky to be able to improve or reverse in these animals which have been bred more for production with less emphasis on longevity or survival traits. So immune competence provides that opportunity of improving the resilience. And in summary, we can say that because we can be able to measure immune competence as a trait, so we are able to improve it. And based on the correlations that we've seen on stress responsiveness and internal parasite, this provides us with an opportunity to be able to improve the health and welfare of the transitioning cow. Not forgetting short-term methods which can also complement this. And I'll just share with you, a few weeks ago, I was in a dairy farmers conference, and one farmer asked me, he said, Josh, how long do you think this will take for us to be able to improve? To be sincere, it's going to take a long time. But if we don't start, we can't improve it. With those few remarks, thank you for listening, and I'll invite questions.
Thank you very much, Josh. Are there any questions from the audience on that particular talk?
Excellent presentation. My name is Roberto Palomares from University of Georgia. And probably I missed when you explained about the evaluation of the cell-mediated immune response, and you said that there was no correlation with the stress. My question is, did you measure the cell-mediated immunity as the circulating phenotype by flow cytometry, or did you do anamnestic response doing proliferation and cytokine production by recall in vitro? Thanks.
Thank you for that good question. So I'll just flip back the slides. Can flip back. Anyway, so what we did is that with cell-mediated immune response, we used skin test measures, which have been shown to be similar to the tuberculin test, where you inject, before injecting the vaccine, you do skin test measures. So you can use a comparator side where you inject saline or buffer, and the test side you inject the vaccine, part of the vaccine. Then depending on the response, 48 to 72 hours apart, you come and do the skin test measures. And using a model, we are able to standardize that data and have a measure of cell-mediated immune response, if you like, DTH responses.
Any more questions for Josh? Gentleman over here.
I would like to ask about the unit in measuring the antibody-dependent immune response. This nanomole per liter. What was measured in this?
So thank you for that question. So what we did is that we used a conventional vaccine, 7-in-1. So before injecting the vaccine, we took some blood just to measure the background of the antibodies. And after injecting the vaccine, we looked at optical density as a measure as well as a measure of antibody-mediated immune response, and corrected the measure after injection with the measure before injection, which we used to incorporate in the model as measures of antibody-mediated immune response. So similarly, you could be able to, you can as well as just measure titer levels, but you don't need to get to that stage because a measure of the optical density will provide similar results, if you like.